as I mentioned, what we're about to have a look at is partly review. So I'm going to get you guys to help me to remember the fact that when you have the equation of a line, there are actually lots of different equations that can represent the same line. There are different forms you can put the equation in, some of which are more useful than others, or they're useful for different purposes. So I want you to help me remember, what are these forms? Ones that you should look at and recognize and know what they are and why they're useful. Let's start with some really simple ones before we get to the more broadly applicable ones. Horizontal and vertical lines come in a form that you ought to recognize. If you have a horizontal line, its equation will be in what form? Y equals. And I mean, in this case, we just put like a letter, like B, for instance. I choose B because in coordinate geometry, we tend to mean B as the y-intercept, which we'll come to in a second, right? Well, y equals B obviously intersects with the y-axis at B. What about a vertical line? This is y equals, so a vertical line would be x equals. What letter would you like to choose?
B.
I'm going to choose
B.
A. Nice and alphabetical and parallel. So for each of these, A and B are constants. So long as you have some number over there on the right-hand side, you'll get a horizontal line or a vertical line. But as we know, most lines are not perfectly horizontal or perfectly vertical. They're off at angles. So now we know a whole bunch of different forms. Would anyone like to throw one at me? Yeah. Okay. General form. Okay. General form has 1, 2, 3 characteristics that make it what it is. For the first thing, the right-hand side is equal to something specific. 0. I start with this one because it's a unique quality about general form. What do you get on the left-hand side? AX plus BY plus C. Okay. Now, the first characteristic is that the right-hand side is 0 and everything else is shoved on the left-hand side. What other characteristics? What can you tell me about, say, A, B, and C? What kinds of numbers do we tend to make them? We tend to make them integers, right? We want them nice and whole. It's easier to write. Okay. So A, B, and C are whole. In particular, A, just as a convention, we want this to not just be an integer, but we tend to like it positive, right? Even though it's the same thing, you can multiply it through the whole thing by -1, since that guy is 0. So it's the same line, but that way at least we're all consistent. And if I say get it in general form, you'll all write the same equation. Make sense? General form is fine. It's not that useful geometrically though. You can't look at that and know any of the features of your line. So someone give me another form. Gradient intercept or slope intercept form. Okay. Now this one is a bit easier to work with visually because once you read off the equation, the gradient is there as a number and so is it's the y-intercept, right? But gradient y-intercept form doesn't roll off the tongue the same way. What is it? Y equals? Okay, you can recognize the gradient, you can recognize the y-intercept, which is why I chose this. Okay. So far so good. We know more than this though, right? Someone give me another one. Give me another one. Let me give you a clue. Gradient intercept is one of them. There's another one which has gradient in it. What's the other one? Point gradient. Point gradient form.
What do you mean?
2-point form.
We'll come to 2-point form in a second. What is point gradient form?
Y minus
Y minus?
Y1
Yep.
equals m x minus x1.
Cool. Now, point gradient goes straight to 2-point formula because if you take m and you recognize that we have a formula for m that is in terms of 2 points, right? If you just substitute the gradient formula in there, what is the gradient formula again? y2 minus y1 on x2 minus x1. If you chuck that guy here and then just rearrange a tiny bit, then 2 points, it just kind of plops out, right? Because look, the left-hand side is already y minus y1. You divide it by x minus x1, right? To get these guys all gathered here on the left-hand side. And what do you get on the right-hand side? What's left? Just the gradient, right? Which, what did we just say? It's rise over run. There you go. So you see how this flows out of this, right? It's just a slight reframing. What do you think? Is that a reasonably complete list?
Okay.
Yeah, we know.
Looks all right to me, okay? There is one more that I'm going to add on to this, which is very useful. It flows straight on from two-point form, and again, like gradient intercept form, which is probably the most common one you've seen before, it's very useful visually, okay? It's not two-point form, it's two-intercept form. It's quite seldom used. Does anyone know what two-intercept form is? General form, you make the right-hand side 0. To get to intercept form, you make the right-hand side 1. Okay? Now, because this is unfamiliar, let me show you how this works. Let's come up with a line. How about 5x minus 2y plus, what's a nice number that we can choose? How about 10 equals 0? So here it is in general form. And as we pointed out before, you know almost nothing about this line, like at least straight away. Of course you can work it out, but it's not immediately obvious. Here's what I'm going to do. I'm going to rearrange this such that it looks like this. Okay? So I want the constant term to be on the right-hand side, and I want it to be 1. So, what shall I do? What would you like me to do as a first step? The constant's on the left right now. Maybe I should subtract it from both sides to get it on the right. So that's going to look like this.
Divide by negative 10.
You agree? Yeah, okay. So now I want to get towards 1. So it's negative 10 right now. So I'm just going to divide it through by negative 10. Well, you divided that through. You better divide everything else as well. Is that okay? All right, let's just simplify this out a little bit. I know this is an awkward way to write it, but you'll see the advantage very quickly. We almost never ask you to have negatives on the denominator, but negatives on the denominator are actually really useful in this case. What are you going to get here if you simplify this and have an x on the top? It'll be negative 2 on the bottom. Just watch out here. What's this going to be? Double negative. So this is plus y on 5. And then there's the 1 that we were after. Yes? Okay. I wonder if anyone's worked out why it's called this. How do you find the x-intercept, for instance, of a line? How do you find the x-intercept? You let y equal 0. So that's a 0, sorry. That's going to become this plus what? Right? So now you solve. Well, there's just a 1 on the right-hand side, right? So x is going to be equal to, surprise, surprise. And if you repeat this process, you let x equal 0, what do you think will emerge for y? Right there. Okay. So this is really nice. This is a great form because you know what? Anytime you draw a line on the coordinate axes, what are the 3 points we expect every time to be labeled on there? 3 of them. What's the most important point on the whole thing? The origin. There's the first point. What are the other 2? Yeah. This intercept, let's call that negative 2. And that intercept, 1, 2, 3, 4, 5. There it is. So if I know what these intercepts are, then I immediately have the line, and you can get gradient out of that if you want. Okay. By the way, what is the gradient? You can read it off this, can't you? It's rise over run. It's 5 over 2. Careful, it's going up. I know that this is negative 2, but the length, the run, is just 2, right? So it's 2.5, as you should expect. Steep line, yeah? Okay, now, when do you use one form? Like I've got 1, 2, 3, 4, 5 to choose from. These 2 obviously you only use in special cases. When do you choose one over another one? For example, why would you use gradient intercept form? Why would you use that form?
To present like a final answer.
Present a final answer? Well, if they ask you to present a final answer and they say nothing, I would actually probably default to this form. It is called general form after all. You can put any line in this form. I'd probably use this form if you want to know, say for instance, are these 2 lines parallel? Right? Are they parallel? Parallel or perpendicular? What piece of information is going to help you answer that? The gradient, right? Have a look at the list here. There's only 2 that require or include the gradient, right? Am I going to go for this one? There's no point. Why would I use this when I can just go straight to the gradient there? Okay? Well, in that case, why would you use this one? When is point gradient form useful?
Yeah.
Finding a
Point.
finding a
If you are supplied a point and they tell you a gradient and then off you go. Okay? So often the form that you use is defined by what information do I have access to. Sometimes that's obvious. Other times it's not so obvious. On the reference sheet that I showed you before, do you remember I sort of alluded to this perpendicular distance formula? It requires this form, right? They won't tell you have to get it into that form. You just have to recognize, oh, there's an A and a B and C in that formula. It's these three letters here. Does that make sense?
What about like the